First off, let's decide what a machine train is. The most classic definition is whenever there are at least 3 machines. That means that there are machine feet that have at least 2 couplings in between them. Here are some examples of some common plant machine trains. A motor coupled to a gearbox coupled to a compressor, a turbine high-pressure section coupled to a turbine low-pressure section coupled to a generator, an engine coupled to a gearbox coupled to a pump, a boiler feed pump coupled to a turbine coupled to a gearbox coupled to a booster pump. So now that we know what a machine train is, what is a complete machine train alignment? Well, a complete machine train alignment considers the machine train as a whole. It considers alignment targets from the manufacturer or alignment targets that are calculated by measuring dynamic movement. When we do the alignment, we employ the fundamental alignment principles to ensure proper shaft alignment. Machine train alignments don't have to be exceedingly difficult. If you use the proper techniques, machine train alignments can be easier than a single coupling alignment. This is because you have options. You have more options on what can be moved, because when you do a machine train alignment, you're moving points rather than moving machines. Problems people usually have with machine train alignments are getting bolt bound or getting base bound, because they start on one end of the machine and align all the way down in succession. So by the time you get to the last machine, you have a move that's either impossible to make horizontally because you're bolt bound, or you have a down move that can't be made because you're base bound. Safety is our #1 concern when doing any alignment. So whenever you start an alignment, make sure that the machine is locked out and tagged out. Make sure that you see for yourself that the machine is locked out and tagged out. Never take anyone else's word for it. Spending a little bit of time on the front end of an alignment, cleaning up, can save you lots of time on the back end of an alignment when you're trying to make a final move. So remember to remove all the dirt and the grease from in between the feet and the base plate. Remove or replace any rusty shims, and check for foreign objects underneath the machine that can get wedged in between the bottom of the machine and the base. Perform a rough soft foot check. To do this, you loosen all the hold-down bolts, and then you fill any obvious gaps with shim. Recognize the coupling types of the machine that you're working on. You have to know before you take measurements whether it's a rigid, a flexible, or you're dealing with a spacer shaft or a jack shaft. Don't make the machine train alignment more complicated than it has to be. Keep it simple. Take all measurements first, then view the alignment as a whole. When viewing the alignment, you have to decide what is movable. You want to fix points, not machines. Now, obviously, there's always going to be some points that you have to leave fixed because of piping. But maybe you could move that point a little bit, a few thousandths, and be able to solve the alignment problem of an entire machine train. And remember, horizontal and vertical fixed points can be different. They don't have to be the same points. Before making any machine moves, we have to consider dynamic movement. We want to consider the coupling targets. We want to consider any calculated thermal growth at the feet, and we want to consider any measured changes that we have of hot to cold or cold to hot alignment across the coupling. Coupling targets come from a few different places. From the coupling manufacturer, from the machine manufacturer, or sometimes you even have in-house specifications for coupling targets. If you don't have any coupling targets, it's best to do a theoretical calculation. This is calculated as a thermal growth at the feet of the machine, because that's where you'll actually make the alignment move. You need to know the material constant of the machine, the distance between the center of the shaft and the machine feet, and then the change in temperature from when it's cold to when it's hot. Instead of using a coupling target or a theoretical calculation, the best thing to do is to measure your dynamic movement across the coupling. This is done by monitoring your dynamic movement across the coupling, by monitoring it at the bearing brackets and being able to actually see how the alignment changes from cold to hot or from hot to cold. All of this different information is combined. The misalignment readings, the coupling targets from the manufacturer, from your in-house specification, or from the coupling manufacturer, and any measured dynamic movement that you have. You combine all of this information together in order to get where you want to move the machine to. The best way not to confuse yourself and to get the correct alignment information is to graph it out. You can graph your cold alignment condition, your hot alignment condition, and any calculated changes or measured changes that you have all on the same graph, and just count squares in order to see where you want to move your machine to. So what are the benefits when using laser alignment for machine train alignment? A full template of the machine train is entered into the computer so the machine train can be looked at as a whole rather than each coupling at a time. You can look at best case scenarios instantly to try out in the computer before actually performing them and discovering that you are bolt bound. All machine train dimensions and past readings are stored in the computer and can be recalled when the machine train needs to be aligned again in the future. Why is Acquip the best choice for your laser alignment needs? Well, at Acquip, all we do is alignment. We're experts in the field. We're able to take current technology that's available now and apply it to new problems. We continually think outside of the box to solve problems that are out of the ordinary. We have experienced alignment engineers who are dedicated to your specific alignment needs. We will go almost anywhere at any time without almost any notice. We guarantee your alignment will be done correctly the first time. Thank you for joining me for this presentation. For more information on Acquip products and services, you can contact our sales office at 407-401-9343. For any technical questions, you can contact operations at 305-538-7101. You can always find us on the internet at www.acquip.com, or you could send us an email at info@acquip.com. Remember, at Acquip, alignment is our business.